Hi guys, how are you doing? I'm here working on exponent rules. So we're going to start with the product rule. When you hear the word product rule, what should come to mind is the word product, see if I can spell correctly, means multiply. So when I say the product rule of exponents, we're talking about when I multiply things that have exponents. So first of all, we need to get a little quick review of what exponent notation is. So if I have 3 multiplied by 3 multiplied by 3, and I'm using the time sign that's the little point instead of an X, so that I don't get confused with the 3x or 3 times 5. If I have 3x 5, that's 3, the variable x, and 5 all being multiplied together. This is just 3 times 5, and it can get very confusing. That's why a lot of times when we get to algebra, or pre-algebra in this case, since you're 8th graders, we stop using this multiplication sign and we replace it with the quick point to mean multiplication, or sometimes we'll do the parentheses to mean multiplication. But just remember that all of those mean exactly the same thing, and they all mean multiply. So whatever's easiest to write is generally what we write. Mathematicians love things to be easy. So we have 3 times 3 times 3 times 3. That is 3 to the 4th power. Of course, this 3 is called our base, and this 4 is called our exponent. And the base is what's being multiplied, and the exponent is how many times it's being multiplied. So that is 3 to the 4th power. What if I have let me erase everything here. What if I have 5 to the 3rd power? Well, that's the same as 5 multiplied by 5 multiplied by 5, which of course this is 5 times 5 is 25. And when I still multiply that by 5 one more time, 25, 50, 75, 100, 125. So that is equal to 125. All of these are equivalent but different ways of writing the number 125. 125 can be expressed as 5 times 5 times 5. It can also be expressed as 5 to the 3rd power. So when we're talking about multiplying exponents, now we're getting into multiplying different types of exponents. So what if I said, and I apologize, my eraser tool is not working perfectly. Doesn't it always just bug you when it doesn't work when you want it to work? Okay, so what if I have 5 to the 2nd power multiplied by 5 to the 3rd power? If you were in class today, you were doing this with us. So if I have 5 to the 2nd power, that means I have 5 multiplied by 5. And when you need a hand, expand. What I mean is sometimes it's difficult to think of exponents when they're in exponential form. So if we put them in expanded form, that's right, this is called expanded form. That means that I'm going to write it with all of the factors that go into this multiplication problem together. Then I'm going to write 5 to the 3rd power as 5 times 5 times 5. And because they were being multiplied together, I still need to multiply them together. So I have a total of 1, 2, 3, 4, 5 5s being multiplied together. That is 5 to the 5th power. So we're going to keep that in mind. That's 5 to the 5th power. So since I want to keep it in mind, I'm going to write it over here. 5 to the 2nd power multiplied by 5 to the 3rd power is equal to 5 to the 5th power. All right, erase all of this, and we're going to have our second problem. Eraser, eraser. I should probably learn how to pause my recording so you don't have to watch me erase all the time. Oh man, I'm getting this new whiteboard app figured out. Okay, so second problem. Let's say I have 3 to the 4th power multiplied by 3 to the 2nd power, or 3 squared. Sometimes we'll say that 3 squared. 3 to the 4th power, of course, is 3 times 3 times 3 times 3. 3 to the 2nd can be expressed, and since I am multiplying these together, I'm going to put my times sign in the middle, and 3 to the 2nd power can be expressed as 3 times 3. Well, when I count my total number of 3's being multiplied together, that's 1, 2, 3, 4, 5, 6 3's being multiplied together. That's 3 to the 6th power. So I'm going to write this down. 3 to the 4th power multiplied by 3 to the 2nd power is equal to 3 to the 6th power. Well, what happens I'm going to erase this again. When our base is a variable. What I mean by the base being a variable is I might have something like x to the fourth power being multiplied by x to the third power. Well, now the base, this part of it, is a variable. It's not a constant. It's not a number. So I'm going to do the exact same process. This is 1, 2, 3, 4x's being multiplied, and I should probably have color coded that so you can see my 4x's being multiplied by my 3x's. And again, I'm going to color code that. X to the third power is x times x times x. So I have a total of 1, 2, 3, 4, 5, 6, 7 x's being multiplied together. So x to the seventh power. So again, I have x to the fourth power multiplied by x to the third power is x to the seventh power. Now, I hope if you were in class or if you're watching this for the first time, that you're noticing this lovely pattern. 2 plus 3 is 5. 4 plus 2 is 6. 4 plus 3 is 7. That's exactly what's happening. So what I'm seeing then is I'm seeing that a product rule that I can use to multiply exponents is that if I have the same base, and they have to be the same base, this does not work if they don't have the same base. This only worked because I had an x and an x, a 3 and a 3, and a 5 and a 5. This only works when they have the same base. Then I can just add the exponents. What we say is a to the m multiplied by a to the n is equal to the a to the m plus n. If I wanted to expand that out so it made more sense, what I'm saying is any base, let's say a, with an exponent, any exponent, I'm going to say 10, multiplied by the same base. It still has to be an a, so I'm going to make it an a. Let's say n is 11 this time. Well, because I know this rule, m was 10, an was 11, then I know this has to be 10 plus 11, or this has to be a, again, same base, same base, same base, but this has to be to the 21st power. And I know that makes sense because if I had 10 a's, and oh my gosh, I don't want to write this out, but we'll just go fast. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Nobody wants to write that out. That's why we have exponential form. Now I have to write the 11s. Oh, I don't want to do that. That's why I have an exponent. All right, I'll do it just for you guys because I love you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have to double count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I know there's 11 there and 10 here. 10 and another 11 being multiplied together. This is the longest possible way to write it, but that is a to the 21st power because there are 21 a's being multiplied together. Wasn't it so much easier to just follow that rule? Well, this rule helps you to simplify your life. It helps you to remember that if I have the same base, I can just add the exponents. All right, keep watching for part 2 to see what happens when I have a variable, but I have another coefficient in front of it. So that'll be part 2. This was part 1. I hope it helped.